Hello dear students. So today I will continue the next part of the syllabus in domestic wiring is earthing. So in the today's lecture I am going to discuss what is earthing, what is the purpose of doing earthing and the classification of earthing. So in the classifications mainly I will discuss plate earthing system and pipe earthing system which is there for your syllabus. Okay. So let us start the session. Okay. In the first slide, so we'll discuss what is earthing. Okay. The definition states that it is the process of connecting the metallic bodies of all the electrical apparatus and equipments to the general mass of earth by a wire having negligible resistance is called earthing. So the definition states that so we are using many electrical apparatus and equipments in domestic or in commercial or in industries. So by connecting all the metallic bodies of the equipments to the earth with the help of wire, there is an earth wire. So having negligible resistance is called, this process we can call it as a earthing. So 2 points you have to remember. So due to earthing, we can give the protection to the equipment under the abnormal condition, and we can give the protection to the person against the electrical shock. So that is a second advantage of doing the earthing system. So if you take any circuit, example this circuit, let us assume that this toaster is not earthed. Okay, that's the first condition. If earthing is not done, if any fault is happen, okay, that may be because of the leakage current, or that may be because of the short circuit condition, okay, or excessive voltage or current due to the lightning strokes, because of any reason, if there is a fault in this equipment, okay, when any person comes and touches the faulty part, so there is a possibility of flow of leakage current to the human body and then to the ground. Okay, that's the first case. So means the person will get the electrical shock. Or the second point is the equipment itself may get damaged because of the excess current. If there is a because every equipment has its own capacity specification with respect to the voltage and current. If it exceeds more than that, obviously the equipment will be get damaged. So because of earthing, we can give the protection to the equipment itself or the personnel who is comes in contact with the faulty part, so he can get the protection against the electrical shock. So these are the two main advantages of doing the earthing. In other words, we can define earthing as earthing means connecting the neutral point of supply system or non-current carrying parts of the electrical apparatus to the general mass of earth in such a manner that all the times an immediate discharge of electrical energy takes place without danger. So you have to understand that the earthing means it is an alternative path for the flow of fault current, so that it should not be there should not be damage to the equipment, or there should not be an electric shock to a person who is comes in contact with the faulty part. So there is an immediate discharge of the all the fault current, leakage current to the earth. So that is the main purpose of earthing. Okay. So we'll discuss in detail what is the objectives of doing earthing. Objective means what is the main aim of doing earthing. So the first point is to provide an alternative path for the fault current to flow so that it will not endanger the user. Dear students, as I said earlier, to provide an alternative path for the fault current to flow, it means that so under the fault conditions, the current will chooses the another path, that is the ground or earth. So because of this path, so we can give the protection to the equipment as well as the protection to the human being. So that is the advantage of doing the earthing. The second point is to ensure that all exposed conductive parts do not reach a dangerous potential. Means the conductive parts of the equipment should not reach a higher voltage level. So because of the earthing, so immediately we can discharge the leakage current to the earth, so that so there is a disconnection of the supply to the equipment. And third point is to maintain the voltage at any part of an electrical system at a known value. So as you all know that, so any equipment is designed with some specification, that is voltage rating, current rating, okay, any other technical parameters. So if you know the value under the fault conditions, so if there is a flow of excess voltage or current to the equipment, then obviously the equipment will be get damaged. So to avoid this condition, the equipment should be connected to the earth so that the leakage current will flow to the earth. So it should not affect to the equipments. Okay. So to give the protection against the damage of equipment, as well as to give the protection to the human being against the electrical shock. That is the main objective of doing the earthing. And what do you mean by good earthing? Good earthing means it must have low impedance to ensure that the sufficient current can flow through the safety device so that it disconnects the supply less than 4.4 second. So the main purpose of doing earthing is to provide an alternative path for the flow of fault current. That's the main point. And how much faster the leakage current will flow to the earth. That is also very important because within a fraction of second, the equipment may get damaged because of the high voltage or high current because of any abnormal conditions. So there is a disconnection of supply less than 0.4 second. So that is we can call as a good earthing. Means the immediate discharge of leakage current should be taken place. So that we can say as a good earthing. Qualities of a good earthing. Qualities means keep the resistance low as much as possible. Second one is it must be a good corrosion resistance. And third one is dissipate high fault current repeatedly. Repeatedly fault occurs in the system in the circuit. So that the whatever the fault current is there, that should be reached to the earth. So that is the protection to the equipment. That we can call as a qualities of a good earthing system. And what is the main purpose of earthing? The main purpose, as I said earlier, to save the human life from danger of electrical shock or death, okay, and to provide an alternative path for the flow of fault current so that it will not endanger the user. That's the main advantage of purpose of doing the earthing. The second purpose is to protect the buildings, machineries, and appliances under the fault conditions. Okay, so these are the main purpose of doing the earthing: to save the human life against the electrical shock and to protect the buildings, equipments, and machineries under the fault conditions. The fault condition may be because of the leakage of current or because of the short circuit conditions or because of the any environmental factors like lightning strokes. Okay, and here are the few points listed. Basic needs of earthing. First point is to protect the human life as well as the provide the safety to the electrical devices and appliances from the leakage current. Okay, and second one is to keep the voltage as constant in the healthy phase and to protect the electrical system and buildings from the lightning strokes and to avoid the risk of fire in electrical insulation systems. So these are the basic needs of doing earthing. We can protect the human lives, we can maintain the voltage constant, and we can protect the buildings against the lightning strokes, and we can avoid the risk of fire in the electrical installation system because of the fault conditions. So these are the basic needs of earthing. Different terms used in earthing, electrical earthing system. Terms means, so earth means what, earth means what, solidly earth, earth electrode, and earth continuity, conductor, and earth resistance. So these are the commonly terms we'll come across while discussing the earthing system. The earth means what? So just we are going to connect the earth electrode and electrical insulation. Okay, the proper connection between the electrical insulation via conductor to the buried plate in the earth. So that we can call as a earth. Earth means what? When an electrical device or any appliance or wiring systems connected to the earth through the earth electrode. So that we can call as a the equipment is earthed. Solidly earthed means what? So connecting the earth electrode to the electrical insulation without fuse or circuit breaker. So that is called solidly earthed. Earth electrode means it is the device. So means it is a conductive plate. You can take an example. It's a conductive rod. It may be metal water pipe. Okay. For the plate earthing, we are using the plate as a electrode. For the pipe earthing, we are using the pipe as a electrode. So that is connecting to the electrical insulation system. Okay. So that is called earth electrode. Different earth electrodes are using for the different types of earthing. Earth continuity conductor means the wire which is connected among the different electrical devices and appliances like distribution board, different plugs, appliances, etc. Means so from the earthing, so there should be a continuity of the earth wire throughout the electrical circuit. So that earth continuity conductor is also very important. And earth resistance means it is a total resistance between the earth electrode and earth. In normally it is measured in ohms. Okay, points to be earthed. What are the points to be? What are the points to be earthed? So normally we are using the 3-pin socket points, okay, and 3-pin plug points. The larger diameter pin, that is the earthing pin, and remaining two are the phase and neutral. Okay, so that is we can call it 3-pin socket points. That's the plug sockets. Or 4-pin power plug should be efficiently and permanently earthed. So the third point, the earth point should be connected to the earthing so that under the fault current, under the fault conditions, the leakage current can easily flow to the earth. So that we can make sure that giving the protection to the equipment and giving the protection to the human being against the electrical shock. And what are the other parts to be earthed? Means all metal casing or metallic coverings containing or protecting any electrical supply line or apparatus. So like example, ironclad switches, ironclad distribution fuse boards, GA pipes, conduits, etc. are should be earthed, means connected to the earth. And you can take the frame of every generator, stationary motors, metallic parts of all the transformers, okay, and that should be connected by two separate and distinct connections to the earth because of the high capacity. So where we need to connect two separate earth wire should be taken from the machines and giving to the connecting to the earth. And what do you mean by equipment earthing? So in case of insulation failure, the primary object of connecting all the above points and apparatus to the earth is to release the charge accumulated on them immediately to the earth so that the person coming in contact may not experience an electrical shock. And the other objective is the heavy current when flows through the circuit that operates the other devices, safety devices, that is fuse or circuit breaker, okay, which is open the circuit. And here is a chart that indicates for the different locations like power stations, substations, okay, and towers, machines, what is the earth resistance should be maintained as per the standard. So for the large power stations, it is 0.5 ohms. Remember, it is unit in ohm, only 0.5 ohm. Substations 1 ohm, small substations 2 ohm, factories 1 ohm, and lattice steel tower transmission lines, that's 3 ohms, and industrial equipment machines and equipments 0.5 ohm. So for all the cases the earthing resistance is kept minimum like 1 ohm, 2 ohm, or max 3 ohm. So as per the standards, the earthing resistance depends upon the moisture content in the soil. So it is the soil may varies from location to location, that's why so we need to keep minimum as much as possible. So maximum 5 ohm or maximum 10 ohm in any other cases. And methods of earthing: conventional earthing and maintenance free earthing. So methods of conventional earthing, that is plate earthing, pipe earthing, rod earthing, strip earthing, and earthing through water mains. So these are the main 5 classifications under the conventional earthing. So for your syllabus, so plate earthing and pipe earthing is there. So that we'll discuss in detail. So first you discuss what is earthing electrode. See this image. So this is the earthing electrode. So this indicates number one, that is the earth wire, and second indicates there is a connector, and third is the electrode. The electrode may be copper plate electrode, or you can take as a pipe for the pipe earthing, or rod for the rod earthing. Okay, so this is the ground level. So this earth electrode brought above the ground level, and this earthing wire is connected properly to this connector. And remember, if you're using the copper wire, then this the plate, copper plate or copper nuts and bolts of the same material should be used. If you're using the GI wire, then the GI plate, GI nuts and bolts should be used. Okay, that is also very important. And this earthing wire connected properly to this connector, and this is the total length of the earth electrode. And here you can see the components of earthing or grounding system. So this is the earth level, that's the ground level. Okay, and here you have done the earthing, that is the earth electrode. And this to the earth, to the earth electrode, to the earthing plate, the cable, the wire, the earthing wire is connected properly. Okay, to make sure that it should be connected properly and carried above the ground level, and through the connecting point it reaches to the main board, the switchboard. And again here you can see in the switchboard the bonded to casing properly. So this continuation should be there. Okay, there should not be any breakage of this conductor, the earth continuity conductor. This indicates the earth continuity conductor throughout, from the earthing to all the devices connected properly. So what happens if there is not continuity? Then obviously there is no connection to the earth through this conductor. So in that conditions, you may get electrical shock, or the equipment will be damaged under the abnormal conditions. So that is the disadvantage of if you not done the earthing properly. And look at the motor. So as I said earlier, as per the rules, Indian standards, so to the metallic body of the motor or any machines, two separate earth wire should be carried and done separately. See, one earthing plate is connected for one earthing continuity conductor, and another is for another. So both connecting to the earthing plate. For machineries, so the two earthing wires should be carried as per the standards because of the high leakage current flow possibilities are there in the machineries. So let us come to the main point, that is plate earthing and pipe earthing system. So only the difference between the plate and pipe is the electrodes used in the plate earthing is the copper plate or GI plate, and the electrode used in the pipe earthing is the GI pipe. GI means it's a galvanized iron pipe. So what is plate earthing? So in this type of earthing, the plate used for earthing either copper type material used for the plate is copper, or GI, galvanized iron, which is buried into the ground at the depth of not less than 3 meters from the ground level. That's the first point. The second point is the earthing plate means the copper or GI plate, which is embedded in alternative layer of coke and salt for a minimum thickness of 15 centimeter. And the third point is the earth wire is properly bolted to an earth plate with the help of nuts and bolts and washer, which is made of copper in case of copper plate and GI in case of GI plate. So let us look at the circuit diagram. That's the main plate earthing system. So this is the diagram of the plate earthing system. Here you can see this is the ground level. Okay. So the technical specifications are mentioned in the diagram. The size of the copper plate is, you can see, 600 mm into 600 mm into 3.15 mm if you're using the copper plate in this plate earthing. If you're using the GI, galvanized iron plate, then the size of the plate should be 600 mm into 600 mm to 8.30 mm as per the standard. And this copper plate should be embedded below the ground level, that is minimum 3 meter length. The length of placing this copper plate below the ground level is minimum 3-meter depth, and also it may be more based on the condition of the soil. And around the four sides of the copper plate or Gia plate, a layer, okay, the mixture of charcoal and salt should be poured, which increases the earthing efficiency. And the layer should be minimum thickness is 15 centimeter, which is mentioned here, 15 centimeter for all the four sides. And this is the 19 mm Gia pipe, which is connected to the copper plate or Gia plate, and that should be connected to the copper plate with the help of copper nuts and bolts and washers. If it's Gia nuts and bolts and washers, which are made with the same material, and that should be connected to the main funnel. And this is the funnel covered with the wire mesh, and this is the cement concrete, okay, and this is the ground level. And above we have the cast iron frame, there's a CF frame, and all these basic structures are made properly. And through the funnel we can pour the salt water, okay, periodically for the maintenance purpose, and where the wire is brought and carried to the main buildings or to the machines. And this is the construction details of the plate earthing system. And if you look at the pipe earthing system, the difference between the plate and pipe is we are here using the electrode as a pipe in the same procedure. But here the advantage of pipe earthing is, so here we can see there is a funnel wire mesh. So periodically we can see whether the earth wire is connected to the pipe properly or not. So there is a possibility of disconnection of earth wire to the earthing electrode, so that can be easily um, identified in the case of pipe earthing, but which is difficult in the case of plate earthing, okay. And the procedure of pipe earthing is also same. Some technical specifications are given as per the Indian standards, that is charcoal and salt, mixture of charcoal and salt layer is poured around the four sides of the pipe earthing pipe. And the pipe used for this is, the size will be 38 mm GA pipe, means the diameter of the pipe is 38 mm, and the length of the pipe is 2.5 meter length. See, the standard value is 2.5 meter length minimum. And before placing the pipe, so the depth inside the ground level is 1.25 meter minimum. And this structure, the final structure is given up to 250 mm and plus 150 mm, and 1.25 meter plus 2.5 meter, total 3.75 meter is the total depth inside the ground. So this is the cement concrete, okay, and this is the construction details of the pipe earthing. So under the fault conditions, so we can make sure that the fault current will move, reach to the earth, okay, through the earthing wire. So that earthing wire is connected to the this plate or pipe properly. So for periodic maintenance purpose, we can pour the charcoal and salt mixture for every 6 months or for every year. So the maintenance should be done, and we need to measure the earth resistance, and the earth resistance value should be kept minimum. That is 1 ohm, 2 ohm, zero point 0.5 ohm, or less than 5 ohm in any other cases. And let us discuss the pipe earthing. The same thing is listed here. The pipe earthing is best form of earthing compared to the plate earthing, because there is a possibility of disconnection of the earth wire to the electrode in case of plate earthing. So that's why the pipe earthing is best compared to the copper plate, and it is cheap also in the system of earthing. A GA pipe of 38 mm diameter and 2 meters length is placed inside the ground to work as earth electrode, but the depth is depends upon the soil conditions. As I said earlier, the moisture content in the soil is also very much important. So that's why we need to do some testing of soil before doing the earthing. Then we can prefer which type of the earthing is suitable in that particular location. The earth wire is fixed with pipe with proper nuts and bolts. Okay, and it can take heavy leakage current for the same electrode size in comparison with the plate earthing. So this is the one more advantage of having the pipe earthing system. So heavy leakage current can be possible in case of pipe compared to the plate, and the earth wire connection with GF pipes being above the ground level can be checked for carrying out continuity test as and when desired, while in plate earthing is difficult. So this is a very much important topic, very much important point in the pipe earthing means for continuity test. Continuity test means what? Whether the earth wire and the earth electrode both are connected properly or not. Here you can see. So this is the pipe. This is the earth electrode. This is a pipe as a earth electrode, and this is the pipe where we are going to fix the earth wire properly connected to the pipe. And this continuity, whether the earth wire is connected to the electrode or not, that continuity test can be done in the pipe earthing easily. But in case of copper plate, so which is difficult to check the continuity test, that is earth electrode, that is a copper plate or Gia plate, and earth wire, whether connected or not. So that will be difficult in case of plate earthing system. And the last one, in summer season, to have an effective earthing, 3 or 4 bucket of water is put through the funnel for better continuity of earthing. So here you can do the maintenance, that is for every 6 months. So we can pour the charcoal on salt water so that it can increase the earthing efficiency. If you keep the earthing efficiency higher, then obviously the earthing resistance will be kept minimum, so that the under the fault conditions all the leakage current can will flow to the